Hello everyone and welcome to the final lesson in Unit 1, Data Representation. Today we're looking at data storage and compression. This is the final lesson within Unit 1 of the iGCSE syllabus, and the syllabus topics we look at today is the understanding of why we need to compress data and also how we compress data using lossy and lossless compression. So we need to understand the differences between them and why we would use either one in different scenarios. So first and foremost, we need to think about why we would ever want to make files smaller. And it's safe to say the biggest reason is to save storage on your device. The smaller we can make a file, the more storage we'll have for other files and will allow the device just to run better, but mainly have more space for other things. So that's the first reason. Other reasons could include to make it faster to send if you're emailing it or sending it over the internet. And in terms of today's world, when it comes to downloading and streaming, the less data that we have to transfer from the internet to our device, the more enjoyable it will be for us. So reducing the file size of a file is what file compression is. It typically involves removing redundant or unnecessary data. So if we can take data out of a file that isn't needed, we're going to reduce the overall size of a file. If you've got a folder full of scrap paper and inside you've got some important documents that you need to keep, remove all the scrap paper which isn't needed, and obviously your folder is going to be a lot smaller and much easier to handle. In terms of the digital world, if we take a file that's 65 kilobytes and make it 13 instead, this will make it faster to send. Okay, so if you're emailing it or downloading it, like we've said, it'll be faster. It'll take up less storage space once it's downloaded, which is good for us. And then it'll take up less bandwidth as well in terms of the network that we are using, and any bandwidth we need to use, we are reducing the required amount. So those reasons as to why we compress are important, and I'll try and explain a bit better about each one as we move forward. So the first one, less bandwidth. If you're using the internet at home, for example, you have a certain amount of bandwidth available to your house. So the bandwidth refers to the most amount of data that can come to your house at one moment in time. Now, if you've got lots of people in your house and everyone's downloading huge files, the bandwidth available will become less and less, which will impact the performance of all the devices in a negative way. So the more bandwidth we have available, the faster things will download, the more enjoyable the experience will be, the smoother files will stream on YouTube or Netflix, for example. So using less bandwidth from compressed files is going to be better for all of us. If you've got a phone on 4G or 5G, you may be on a plan that gives you 50 gigabytes of data per month, for example. And the bigger the files are that you download, the more this will go down. Say, for example, you stream a film on Netflix that's in 4K and the file is 1 gigabyte. So after you've watched it, you've only got 49 left. If the file was compressed to 500 meg, then you'd have 49.5 gigabytes available instead. That's not accurate for a 4K movie, but just as an example, the smaller the files are, the more data you're going to save. Now, when it comes to storage space, this is the storage space literally on the device. On the physical device, on your storage of your phone, for example, or on the hard drive of your PC, compressing files and making them smaller will allow your device to store more things. Typically on an iPhone now, the cameras are that good. Every time you take a photograph, it takes up about 5 or 6 megabytes. So the more photographs that you take, the less space you're going to have available for the rest of the phone, which will impact how the phone works, if you can download certain things or just generally store different files. So again, if we can compress these files to a smaller amount, it's going to free up space. Okay, so less storage space required when files are compressed. And then finally, a shorter transmission time. So making a file smaller will make it faster to send. Huge files that are measured in gigabytes, for example, will take longer to download than files measured in megabytes. So it'll take a shorter amount of time in terms of transferring it from one device to another, whether it's over the internet, whether it's via Bluetooth, sending a WhatsApp message. All of these things, when we transmit data, will be affected by the size of the file. Now, compression is just a name given to the algorithms which reduce file sizes, okay? The algorithms that are used are just instructions that do certain things in order to reduce the size of the file. And they are typically used within sound, images, and video files. These tend to be the biggest files that we work with. And as we've said, images and videos in particular are starting to become really big with the quality of the cameras on most phones these days. So being able to compress them without losing too much quality is a good thing. But before we move on, the two compression techniques that we need to understand are lossy and lossless. Okay, they're quite different in the way that they work. The first one, lossy, will remove data that might not be needed. Okay, I say may not be needed, and I'll come to that in a minute. What's more important about lossy compression is that the data is removed permanently. Once you compress a file using lossy compression, you cannot get it back. So for example, redundant data, I mentioned in the last lesson about a digital audio file. If we can remove background noise from a file that's taking up space in terms of a sound file, that data is redundant, and if we can get rid of it, we will reduce the size of the file without affecting quality. But in an image, for example, the only way that we can remove data is by either reducing the color depth or taking out pixels and lowering the resolution, and that will affect the quality of the image. The file size will go down, but the data is permanently removed. and we cannot get it back. So lossy comes with a price, and it's all about balance. We have to weigh up quality and size of the file. And it's a balancing act to have good quality, but also a reasonable file size. The higher the quality, the more it will weigh, and the size of the file will go up. And obviously, if we reduce the quality and it becomes lighter, the size of the file will go down. So again, it's just finding that middle ground of finding a balance, okay, between quality and the size of the file. When it comes to lossless, no data is removed whatsoever. It keeps the original data exactly how it was in the first place. So obviously this seems to be much better, but it's not as effective when it comes to reducing the file size. Lossless compression can't reduce the file size as much as lossy compression, but what it will do is it'll keep the original file that you had in the first place without losing the data. So as an example of lossy compression, here we have an image and it's being compressed twice. The original picture is 824 kilobytes. And as we've mentioned, JPEG is a lossy format compression. Now, if we compress this image 50%, by taking out 50% of the pixels, you can start to see in some areas it's becoming pixelated and the quality starts to reduce. However, if you look at the file size, it's gone down dramatically. You've gone from 824 to 76. If we then go on to the 80% lossy compression, you can clearly see the pixels here, and also the quality of the fur in the dog has gone down also. But the file size has again been reduced. So once we get to this state, we cannot get the picture back to the original state. Lossy compression permanently removes the data, so we cannot get back to the original state after it's been compressed. A perfect example of this is if you take a picture on an iPhone and you have the original picture stored in your Photos app, when you send it on WhatsApp, WhatsApp will use lossy compression to reduce the file size, send it to your friend, and then your friend will receive the compressed file, which might not be as good quality, but it was able to send it at a good speed. Because it uses lossy compression, your friend cannot get it back to the original state that it was in. So sending an image on WhatsApp or even a video will use lossy compression in order to make the sending of the file quicker and obviously a lot smoother. Another thing we can think of is on YouTube, where we can change the resolution of an image. Obviously these numbers go up to 720, even 1080, and obviously 4K. Now, as the quality goes up, the file sizes get bigger. If your internet isn't that strong and you're trying to stream a video in 4K, the file size is going to be quite big and it might start to buffer. However, if you choose one of the lower ones, the compression techniques used by YouTube allow it to stream a lot smoother, but the quality will go down. Another thing you might have noticed is if you send an email on an iPhone and attach an image, it might ask you to compress the image so the file size goes down, which will again reduce the bandwidth and make the file size smaller so that it sends more quickly via an email. So the actual size was 1.1 megabytes, but we can choose to reduce it to any of these options above. Again, as I've mentioned, when the person receives the compressed file, yes, they'll have a smaller file, but they cannot get it back to the original quality. You cannot revert to the original state that it was in. Lossless, on the other hand, uses an algorithm that looks for repeating patterns of data. So when data repeats itself, rather than store this data individually, we can use patterns to simply store how many times that repeated data exists. Perfect example, you've got a string of text here, which consists of 16 characters. So as we've mentioned in the previous lesson, if we used ASCII for this, 16 bytes is used to store this string of text. 1 byte per character equals 16 bytes of data. So in ASCII, it would look like this, and then obviously the computer would convert that into binary. Now in this scenario, we've got repeating patterns of data in that A is repeated, B is repeated, C isn't, but D is. So with repeating patterns, what we can do, rather than save each individual letter, we could just simply state how many times that letter repeats and store that number instead of each individual letter. So you can see we've got 4 A's, 6 B's, 1 C, and 5 D. And by storing a number and a letter, we're only taking up 8 bytes as opposed to the 16 bytes that we originally said. Run length encoding will look for these patterns and reduce the file size in that way. And the difference to lossy compression is that here, no data is lost. We can quite clearly recreate the file by simply printing out 4 A's, 6 B's, and so on and so forth. No data will be lost. Now, the problem here is that data doesn't really exist in this format, especially when it comes to characters. There's not many languages in the world that will have repeating patterns. In fact, there aren't many words that have more than 2 letters together. So when it comes to text, it doesn't have a huge impact in terms of how small it makes it, simply because there aren't that many repeated letters in words. However, in images, if you've got an image that contains the same color, for example, it's easy to store how many times that color exists in a picture rather than storing each individual pixel. What a bitmap picture would do in this scenario is store each individual block here, as you can see in purple, as an individual binary number. So each pixel needs storing in binary, and if we think back to our last lesson with digital images, the more pixels we have, the more binary numbers there are, and the bigger the file size will be. Now what lossless compression will do, rather than count each individual pixel, it will just say we have the color purple here, and we've got 9 instances of this color purple. So there are 9 pixels in this row, yet we don't have to store each individual one. We're only storing the color and the amount of pixels that it has. So that's why when you've got pictures with the same colors throughout, lossless compression can work very, very well. As you can see in the next row, it tells us we have 2 purple pixels, then 2 red, then 1 purple, then 2 red, and then 2 purple. So although this row wouldn't be that effective, the rest of the image you can see as the pattern continues with only the 2 colors visible, the file size would be reduced greatly. From 81 individual units, we've now only got 50. So rather than storing 81 binary numbers, we're only storing 50. So it's nearly halved. And essentially, in the file size, this will almost nearly halve. This whole process, guys, is called run length encoding, or RLE for short. So in a typical exam style question, it might refer to lossless compression and you have to describe how it works, in which case you would say run length encoding looks for repeating patterns within an image and stores how many times the color is displayed rather than each individual pixel. The technique used is run length encoding. So images like this one displayed, or even flags of a country, for example, lossless compression works really well and file sizes can be reduced dramatically, and we are left with really small file sizes, yet we keep the quality of the image because no pixels are lost. So as lossless compression keeps all the data, for things like documents, it's absolutely necessary that if you need to keep a file exactly how it was before you compress it, then you're going to have to use lossless. Another example here is with a programming statement. If we used lossy compression on these lines of code, there's no way this program would run. So lossy compression would not work when it comes to things like lines of code, or just if you genuinely need to keep the quality of the original data, for example, in an image. So here, this will clearly affect the running of this program and make it almost impossible to understand or even fix. Here we've got some common file types that you might recognize. In the last lesson, we discussed the image ones. We said that JPEG and PNG were bitmap images, but in terms of lossy or lossless compression, JPEG is lossy and PNG is lossless. So again, in an exam, if it asks for a particular style of file format and its type of compression, then we need to show awareness of these. A zip folder or a zip file is a lossless form of compression, and it works typically well when we are compressing text documents or any files that need to stay intact and the original data needs to be kept. A GIF is another bitmap image, and this is lossless as with PNG. Sometimes they include animation. MP4 is a common video file format, and this uses lossy compression. The same with MP3. So that's also lossy, but that one's used for music or audio. And then as mentioned in the digital audio lesson, FLAC and ALAC are lossless in terms of music. So these are lossless compression techniques used for audio files. And then as always, guys, some exam style questions to finish off. Pause the video if you like, and I will go through the solutions shortly. So explain the following terms, starting with data compression in general. So data compression refers to reducing the overall size of a file. So reducing the size of a file, which means we have to reduce the amount of data stored, which means the reduction in bits / data stored. Run length encoding was a lossless compression technique, which looks for repeating patterns in data. Repeating patterns, and will store the amount of times this data appears. And you could give an example there and mention, rather than saving the word A, we'd have 4A instead. So rather than saving each individual letter, we just say that there's 4 A's overall. And then lossy and lossless compression and the difference between. So lossy removes data permanently by reducing the quality. However, lossless will not lose data and the file will stay intact. So that's it for Unit 1, guys. This is the final lesson in terms of data representation. We've covered quite a lot and we've got a solid foundation to move on for the remainder of the course. The next video, we'll see exam style questions from Unit 1, and I will go through the techniques required by exam boards to see exactly what they're looking for in exam style questions. And I'll try my best to cover all grounds in terms of different questions from different topics within Unit 1. Otherwise, well done if you've made it this far for completing Unit 1. And I hope to see you in Unit 2, where we'll look at data transmission and how data is transferred from one device to another. Okay guys, so hope you've enjoyed it and I will see you again soon.